In this video, we'll be learning about how different components in an electric circuit affects the amount of current flowing through the circuit. Okay, first we'll just quickly have a look into the pictures, and then we'll be actually doing it in the lab activity, virtual lab activity. Okay, so here what I have done is I've taken two batteries, okay, and I've connected the ammeter, the voltmeter, the bulb with the key. Okay, now in the next picture I'm just changing the bulb. Okay, we don't know the actual voltage, so how much power the bulb is, so I'm just replacing it with the bulb. So can you see the difference, the amount of glow in the bulb that it is showing? Okay, even in the reading of the ammeter, if you see here in this it's 1.80 ammeter, means that much current is flowing, and here if you see it's 0.018, so the bulb is not at all glowing. Correct. Then after removing the bulb, I've put two resistors of the same type, connected them together one after the other, and the voltmeter. So can you see the ammeter reading 0.90? Okay, so I'm not changing my batteries. So the voltmeter is going to be 18 volt every time. So just keep watching how the current in the ammeter is changing. Okay. Next is I've changed the resistor. The previous resistor it was 0.90 when I had used two of them, and now here I have used one of them. So the ammeter reading is 0.018. Okay. So both the resistors are made of different material, and they are two different conductors. Okay. Now for a change, I'll put a pencil. But if you closely look at it, when I'll be showing you the virtual lab also, the pencil is sharpened. So the lead of the pencil is connected with the wire. Therefore, it is showing a current flowing in the ammeter. Sorry. If it's a wooden pencil without sharpened pointed edge, then no, then also there will be a mild current flowing. It's not that zero current will flow, but mild current will be flowing. Okay. So let's do an activity in the virtual lab with the same stuff, and let's see what do we observe the same thing or not. Okay. As you can see, I've connected two batteries. My ammeter is connected. My voltmeter is, I've just placed it below. My key is there. Okay. The different stuff that I'm going to connect. The first bulb, the second bulb with high power. The two resistor wires which I'll be connecting together. The second type of resistor wire, and then the pencil. Can you see the sharp edges? The lead pointed leads. Okay. So let's first connect the first battery. Okay. Sorry, not the battery, bulb. Right. So let me put my voltmeter connected with it. Correct. Let me switch on. So can you see 18 volt, 1.80 current ammeter. Right. This is what we saw in the picture also. It's more brighter. Okay. So let's remove this. Let's place my other bulb. Okay. Clear? Let's put on the switch. Okay. The voltage. Can you see 18 volt, 0.018 ammeter reading is showing, and the bulb is like really very mildly glowing, not even glowing we can say, right? Let's switch over and let's put the resistor wire. Okay, first we'll put one resistor wire, then we'll put the same type of wire too. Okay, so let me just shift this and this. Let me put one of them. Okay, so 18 volt, 1.80 ammeter reading is showing. Okay, so let's put the second resistor wire here. Okay, so let's see the ammeter reading. 18 volt, 0.90, right? Okay, let's now change the whole resistor itself. Correct? Let's put the key on. So voltage is 18, 0.018. Can you see not a single electron or the ball, blue balls which are represented by electrons is not moving because the resistance is very high. The battery is unable to send the required amount of electrons to flow. It's insufficient. Okay. Okay, let's place the pencil. Okay. Sorry. Okay. Can you see the pencil pointed as I mentioned? They are the pointed parts with the voltage. So can you see 18 volt 0.72 and you can see the blue balls moving. So as the component in the circuit keeps changing, the amount of current flowing is changing. We have not changed the batteries. We have not done any change. We have just changed the components. Okay. So the amount of current flowing is changing. So certain components allow an easy path for the flow of electric current, while others resist the flow. So electrons are not completely free to move within the conductor. They are restrained by the attraction of atoms among which they move. So motion of electrons through conductor is retarded or it is reduced by this resistance or this blocking of the electrons by the conductor. Okay, so component of a given size which offers low resistance is called as good conductor. Okay, so a component which is giving very less resistance, it's a good conductor, which was my first bulb. Okay, a conductor having some appreciable resistance is a resistor. The two resistors of the same type which I had connected. Okay, and the component which is offering higher resistance is a poor conductor. And an insulator is something which offers even very high resistance. Okay, so let's go back to the pictures and let's name them based on whether they are insulators, good conductors or what. So this bulb is actually a good conductor because it's allowing sufficient amount of current to flow. Correct? So it's a good conductor. Okay. Next, let's talk about the next bulb. It's nearly no. It's a good conductor, but here the battery is not sufficient to satisfy the amount of current required for the bulb to glow. So we'll mention good conductor. We are not even telling that because the circuit is not, the battery is not sufficient. Here we'll see it is again, what is it? Yes, it's a resistor, simple resistor, giving what we say, a fair amount of resistance. So it's a resisting power. According to this one, we can say it's a resistor. Sorry, my spelling. Okay, let me just change it. Okay. It's a resistor. Okay, it is giving a fair amount of resistance, blocking the amount of current flowing. What should we call this? Yes, it's an insulator because it's totally stopping major amount of electrons to pass. Okay, same way. What about this one? It can be taken as a resistor, it can be taken as an insulator. Okay, it can be both. Here let's talk about it as an insulator or let's say a bad conductor, not a good one. Okay, here. So again, a component of a given size that offers low resistance is a good conductor. Appreciable amount of resistance is a resistor. High resistance is poor conductor or bad conductor, one and the same thing. And same size which is giving higher resistance is insulator. Hope this is clear. Now factors which are affecting the resistance of a conductor. So if you see, I've taken 4 pictures. If you carefully observe here, there is a bulb, okay, which is connected with 2 wires. One is the black one and the yellow one, which is connected to the battery, and from the battery, it is connected to this rod. Can you see these 2 endpoints? These are the 2 terminals which are connecting the battery. The battery or the circuit endpoints with the rod. So if you see the extension of the rod which is connected is only this much. So this much length of the conductor is connected with the circuit. So the bulb is glowing. Okay. Now come to the second picture, that is this picture. Can you see the glow of the bulb is reduced a little bit? That is one observation. The second observation is the length of the wire has increased here. Yes. So this has become this much big. So have we increased the length of the wire from first case to second case? Yes. So is the glow of the bulb less? Yes. Okay. So let's go to the next condition. Still a little bit more increase in the wire. That means the length of the conductor we have increased. So is the glow in the bulb reduced drastically? Yes. And when we are taking the total length of the conductor completely full, okay, the bulb is not glowing. Here the conductor is a nichrome wire, it can be a metal rod, any metal rod. Okay, so what we are trying to show here is as the conductor length kept increasing, the amount of current flowing in the bulb was reduced. So this is one of the factors on which my resistance depends. That is the length of the conductor. The second factor that will depend is the thickness of the conductor. Okay, so we are going to talk about that. The factors on which the resistance of a conductor depends is, as per the activity, the current in the circuit is 1/2 when the length of the wire is doubled. That is the last picture. This picture. Correct? Or you can take, yeah, okay. Next, the current in the circuit is increased when the thickness of the wire is increased. And the rule should be the thickness of the wire is only increased, the length of the wire and the material are same. Okay. So current in the circuit changes when the wire of different material of the same length and same cross section is being taken, which we already saw in the condition of good conductors, bad conductors, resistors, insulators, where it kept changing the material. Okay, so by applying Ohm's law, we observe that resistance of a conductor depends on the length of the conductor, the cross-sectional area of the conductor, and the material, the nature of the material. Okay. So let's put it mathematically. So resistance of a uniform metallic wire is directly proportional to what? Its length. If you increase the length, current increases. If you decrease the length, the current decreases. It's inversely proportional to the area of cross section. The more thicker the conductor is, the less amount of current will flow. The more thinner the current wire is, or the resistance, the conductor wire is more thinner, the amount of current flowing will be more. If the conductor wire is more thicker, the resistance increases, so less current flows. So thickness increased, less current because resistance is more. Thickness reduced, resistance is less, so current is more. So we are saying resistance is proportional directly to the length. Resistance is inversely proportional, therefore 1 upon A cross-sectional area. Let's combine these two, means we are multiplying these two. So we'll get resistance is proportional to L by A. Now we have to remove this proportionality sign. So we'll put A equal to, that means there will be a constant of proportionality, and this is called as rho, R-H-O. It's a Greek alphabet and it's written like this. Okay, rho. And it's a constant of proportionality. So the term which we use here for rho, like R is resistance, the rho is called as electrical resistivity of that particular material. Am I clear? So electrical resistance is what? It is a characteristic, okay, of a particular property of the conductor. It's a very specific property of the conductor. For good conductors, it's different. For bad conductors, it's different. For insulators, it's different. Okay, so its unit is ohm meter. Okay, and it varies with temperature for the same material. Metals and alloys. Alloys is mixture of different metals together. Melt different metals and mix them together. Okay, so metals and alloys have very low resistivity because they are very good conductors of electricity. Okay, so their resistivity will range from 10 raised to minus 8 ohm meter to 10 raised to minus 6 ohm meter. Because they are good, therefore they are called as good conductors. It's either way. They are good conductors of electricity, therefore the resistivity is low. Or you can say because the resistivity is low, therefore they are good conductors of electricity. Rubber and glass have a resistivity of the order 10 raised to 12 ohm meter to 10 raised to 17 ohm meter, and they are called as an insulator. Okay. Now, have you seen these type of wires? I mean coiled wires. This is actually inside a water heater, electric water heater, and this is inside the toaster. The toaster is where you put your bread to heat up. Okay, so resistivity of alloy is so high that it is it's very high compared to the metals from which this alloy is made. Okay, suppose if I take iron, zinc, copper, I melt these in different proportions, and suppose I'm taking 60% of iron, 20% of copper, and 10% of zinc, and I melt it and I mix it together, I get an alloy. So that alloy will have more higher resistivity than zinc, copper, and iron. So alloy do not oxidize, means it will not burn at high temperature. Therefore, it is the main reason why they are used in electrical heating appliances like toasters and electrical heaters. Okay. Tungsten is something which is used in the filament, the thin wire inside the bulb. That's called as the filament. It is again having high resistivity, so it will not easily burn off at higher amount of current flowing through it. So tungsten is used in bulb filaments of the bulb. Copper and aluminum are used for transmitting electrical transmission lines. Okay, so in this one we just saw what is resistivity, the factors on which the resistance depends. Okay, thank you.